Hi everyone, in this project I will talk about deep learning in medical diagnostics. Nowadays deep learning provides us a wide range of opportunities for using in different spheres of our lives, and medical diagnostics is one of the most important areas. We can use ultrasound images or healthcare records or lab tests. Also, we can use wearable devices data or pictures that we can make using our smartphones. And due to high importance of early diagnostics and reducing the work of healthcare providers for the cases that are not threatening. We can use our smartphones, for example, for fast and simple preliminary diagnostics, for example, in the case of skin cancer. Here I will show that the usage of neural networks can make skin cancer diagnostics easier and faster, of course, with the help of healthcare providers in the case where the skin cancer can be suspected. Uh, the first and very important issue when we are talking about the skin cancer is its appearance. For example, skin cancer can have a different type of border, a different color in comparison with something normal. And skin cancer detection using smartphone application can make us go faster to get necessary treatment. I got two data sets from Kaggle. They are not big enough, and that is why I merged them, considering that they can overlap. So one of the data sets was pretty small, but a little bit balanced, and the other one was not balanced, so I restricted the number of images for the nevus here as soon as I will get better result, because otherwise we can get 67% accuracy if we will put all outputs the same, because one class is 67% of the whole data set. So to merge these data sets, I created the Python file where I added some code. I extracted one zip file manually, and it had a pretty well structure. I just deleted two folders because the smaller data set consists of 9 classes, and I merged them and used only 7 classes that were in both data sets. And the second data set consists of folders and files mixed all up, and the CSV file, which contained the necessary information about the diagnostics and file name, what I used. I put all the files into this skin cancer folder, and after that I got one big structured data set which was used for further modeling. The total data set description. Here is every class is described here in this table. So we see a lot of images of these two classes and the other class, and here are some classes that are a little bit smaller. I worked using Google Colab and created their train data set, which consists of over 4,000 images, and test data set, which was a little bit smaller. Here are the class names that were defined through the folder structure and the images that were used. Some of them are cancer images and some of them are not. First of all, I tried to use the easiest model that can be used, and it gave me pretty good accuracy, considering that there are 7 classes and the chance level is 14%. At the same time, the number of images is not very good for deep learning modeling. Here are the training and validation accuracy and loss functions. And after that, I try to make the prediction on the same testing data set, and it was not bad. Here are a lot of elements on the diagonal which are defined correctly, and less elements on the sides. It was pretty good. After that, I added more layers, and it was not much more better, but it was slightly better. Also, I was trying to use a data generator to get more images, but the outcome was not outstanding, so probably in this case, data generator doesn't give us a lot of information, a lot of new information to train the model. So here is the confusion matrix. It looks good, but not very good, of course. So in addition to that, I was trying to use 2 pre-trained models. One of these models is exception model, and I fine-tuned 4 lawyers. Here they are, and trained the model. All the models were trained for 50 epochs. And here are the accuracies and the loss functions. If we look at the confusion matrix, it is a little bit better, but not outstanding. And in addition, I calculated those class accuracies for every single class. Here I try to use the data generator for the same exception model, and it gave me a little bit better result. It was 72% accuracy, and a slightly better result for the cancer detection here. Also, I was trying to use another model without data generator. It gave me good result, but it was not better than for exception model. But with data generator, it gave me strange result. The model was diverging after 5 epochs here, and it did not came back. So it was the worst result. For probably this model is not suitable for the skin cancer detection. Here is the table for result comparison for the models. We got a good result for six convolutional lawyer model, and the best result is here for exception model with the data generator. It is 72%. um, it is good for this data set, which is not very big. And here is the confusion matrix for the exception model with data generator. I would like to mention that when we are using data generator, then the number of images that were used for prediction is a little bit smaller, because I have to use batches to get predictions. Otherwise, I got strange results, and so I use it like this. So the batch size is 64, and everything that is over this number is what was not used for prediction. So finally, I would like to say that a 72% accuracy is pretty good for multi-class classification problem with 7 classes, but it is not perfect, of course, and it can be improved using more files, more images, and this model can be used for further development, and some people are trying to use these in their applications, and it is perspective to my mind. And I think smartphone diagnostic will be on the rise, and we have to remember that nowadays there is still the high chance of error, and we have to use several methods to check the diagnosis. Though the chance of human error exists either, and both methods can help us reduce the chance of error anyway. Uh, Thank you for your attention.